Hi everyone, my name is Blaze Cook, and I'm going to be going over my final advanced game programming project about an event dispatcher. An event dispatcher allows you to map functions to be called whenever certain integer objects or string objects are passed to a message passing interface. So my first task was to implement the message passing interface, and then my second task was to allow parameterized method passing for inherited objects. And the first part was actually pretty easy. I just made an enum about the different uh, constants that I really wanted to emulate in my event system. I can add or delete them at will. The second part was a little bit more confusing. I actually needed to go ahead and define some basic prototype functions using some generic function pointer definitions to allow myself to pass some void pointers, which is the basis of inheritance for all C applications. A void pointer is a pointer to anything, in case you didn't know that. So whenever functions want to add, whenever objects want to add a function to the event dispatching body, they create an instance of class subscriber, and they tell it what method is going to be called and when it's going to be called. So I went ahead and made a quick little example. It's using 3 subscriber objects right now with a little bit of different functionality. I'll go over the simpler ones first. If I want to have an object that has its update method called every time event update is received by the event dispatcher, this is the code I can do. It's pretty simple. It uses my subscriber object, so it makes a new subscriber from one that's in the header, and it tells the subscriber who the owner is. So whenever the owner goes null, the subscriber will automatically delete itself, which I find rather useful. And it sets the method to be an instance of the game update method. That's what the standard bind is. If I just wanted to have every object of game thing update with the same parameters and the same sharing all the same variables, I wouldn't have to standard bind. But I do need to bind this to the game update, and it has an empty parameter. So I don't know what the parameter is, so I just tell it that it's a placeholder, which somehow works quite nicely. Standard placeholder is a C++11 feature. Standard bind is a C++11 feature, and standard function is a C++11 feature. So unless you're running latest run-of-the-mill compilers, you won't even be able to use this kind of dispatch system in C++. But besides that, it's actually really useful. So if I want an object that can update and render, I just give it an update method, call it whatever I want. I give it a render method, same code, call it whatever I want. Update, render. As long as the functions I'm giving it match these prototypes, which the subscription function is just the method that you want to get called, and the calling condition function is it's about using complex conditions that they're not just Boolean or this event was received. It's going to use the complex condition to evaluate whether or not the method needs to be called. Now you're asking why you can't just put this in your update method. Well, you probably can, but what if you want to only make a large explosion if the W key has been pressed first? Well, key press W, that would be a nice event. So if that is called, then you could go down to your 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 condition and say, hey, I received the W event. Do I need to blow something up? So that's how that can be used. But if you just want to subscribe to general events, then that's pretty easy. So I'm going to make 10 of my game things, put them in a list called game stuff, and then I'm gonna populate my dispatch event with some of my dispatcher service with some events already. Now you will not have to do this at all if you ever use this code, but it guarantees that the threads will not execute orderly based on this little while loop down here. So I'm just going to show you a quick little example of what actually happens. So, bunch of output because we're in a while true loop and we're printing. Anyway, as you can see right here, so before events have been dispatched, it's right there where before events are dispatched. So then we dispatch an event, and then after they're dispatched. They happen right after each other, and yet then the events are processed. Now it looks like it's running in the main thread until you go all the way down to this little piece right here that shows that these two events are actually, that these two threads are executing concurrently. So while you're updating, while you're telling your event dispatcher to update, you could be fixing some GUI code, or you could you could be rendering the previous frame while you're updating the next one. That would also be pretty cool. You can do other things like schedule pathfinding, uh, tell a class to dispatch an event to itself in a second, and then that's all your timing code in your entire game right there. It happens threaded in the background. You could tell your networking class that whenever you receive a network event, call this method, and then that would be that. You wouldn't have to check network events every frame. What's really cool is that if you're using event handling for input, then you can actually check for input mid-frame. So if you're on a computer with a low frame rate and you're only around 10 frames per second, you're going to check for input once every, what is that? I don't know, 40 milliseconds? Right around there. So once every 40 milliseconds, in some first-person shooters and highly intense action games, that's going to be way too long. You're going to try to turn left a little bit, you're just going to spin circles because you're not checking input throughout the time that you're simulating. So if you check input throughout that time, then you're able to correct the code, and even though you're only rendering at 10 frames per second, you could make the input feel like you're at 60 frames per second or even 120 frames per second. So you could have realistic input and delayed rendering, and your game would feel normal, which is how they do it in the industry. I wish I had a better example. I meant to do a graphical version, but I was actually having problems. So the first issue I had, if you ever use a system like this, is that whenever you pass parameters as void pointers, note that this function terminates almost immediately. So if I pass this reference, this needs to be a permanent reference that will not be garbage collected or nulled out in between when I pass it and when it's actually called, because it doesn't get called here. It schedules it to be called at a later date whenever the dispatcher gets around to it. So I was just saying, like, pass the value 5. What? So I was just saying pass the value 5, but then that was erroring out because 5 is it it's there, it's good for this method, but it's not good for any of the following methods. So I actually had to make a variable, call it delta time, and set it to 5, and then I could actually pass it. So that's about how useful this thing is. I find it great for whenever I want to run functions, and I don't know. Whenever I want to run functions of a class, and I do not need to loop through all of my objects and find out which ones I want to call the function on. Say our player class that we had could have an event scheduled for whenever it was hit. So our player and our infantry that we made for earlier, the infantry could have a method that turns it to a skull, and that method needs to be called with a complex condition based on if it was hit. So the physics engine would dispatch collided events with the event data of where it collided, and then the infantry objects would all get their calling conditions evaluated every time one of them hit something. Every time something was hit, all the calling conditions would be evaluated, and then the calling condition could say, "Hey, I need to turn to a skull," and all of this can happen without the physics system ever knowing that an infantry object exists. It just knows that it needs to dispatch this event that says something over here has been hit. I find that really cool. It allows your game to be a little bit more memory efficient. It also allows it to execute faster. This dispatcher service is delayed execution of methods, like guaranteed ordered delayed execution, which is, I don't know, I kind of like that. You can schedule entities to notify other entities whenever they destroy themselves. So if you have a class fall out of scope and its destructor is called, you could have an event in the destructor that says, "Hey, the object at this pointer no longer exists," and then everything that has subscribed to an event of object destroy or whatever you want to call it would get notified that, hey, if I'm holding a reference to this, I need to set it to null, and that can work pretty well as well. But I really find it useful that while I've scheduled an update, I could be rendering the last frame right here. Or while I'm rendering the last frame, I could be getting input for my GUI interface next frame. So that was my final project. It turned out to be a whole lot harder than I actually thought it was. Finished it a couple weeks ago. Have been trying to get working examples, and that reference issue was really messing me up. So if you ever feel like passing parameters, use your void pointers and use them wisely. That's about it for my final project. If you have questions in class, just let me know.